Okay, in this video we're going to try to wrap up optimization. Um, so that's kind of nice. So we did one of these with like a page, and then the text was around there. I'll do this Norman window one for you, and then be aware that you should try this one, number 19 in the book. I think we're in 3.7. So be sure you try that one. These are, speaking in the year 2025, I can tell you that it's either going to be that if you're going to be asked this on a test or quiz, if you're going to be asked this on the test, it's either going to be this guy, the rectangular print, this guy, the Norman window, or something like this where a farmer has to make a fence, something very close to this. Okay? I didn't like the wire one that we did a little while back, and I didn't like the closest point, so I'm not going to subject you to that. So you get three types basically of problems that it could be. Let's deal with this Norman window now. So we see that this would be y right here. This radius, I guess, is x over 2, because this is x. So we want the perimeter. The perimeter is 16 feet. And we want the area to be a maximum. So area to be a maximum. So the area of this thing is going to be x times y plus, so that's the area of this that we just found, x times y, no problem, plus the area of this. This is a circle, but over 2. So I'll do pi r squared. And I'll divide that by 2. So this is essentially what we want to maximize. And we need to make sure the perimeter is 16 feet. And the perimeter is x plus 2y. That's this. A y, an x, another y, and then half of the circumference. So the circumference over 2, which is pi times diameter, really. So it's really going to be pi x. That's diameter. Pi times diameter. So 2 pi r, right? So the 2 gets rid of this 2. Okay. So we know that this is the equation we need. So let's get rid of y potentially, because I think if we put something crazy in here for x and square it, it's going to be really annoying. So let's just get rid of y. So 16 minus x minus pi x over 2 all over 2 is y. Not great, but we got to do what we got to do. So let's see if we can rewrite the area with that in it. I'll make this pi x squared over 4. And then that's divided by 2, so I'm going to make this divided by 8. Okay. And then if I can combine this at all, it'd be great, but I guess this is 8 minus 16 over 2. 8 minus. And then I guess it is, geez, how could I do this? Negative x minus pi x over 2. I can make this over 2, like that. Then it would just be one fraction. So would it be maybe negative 2x minus pi x all over 4? I think that's good. Let's make sure. That divides out to negative x over 2, which is this. This divides out to pi x over 4. Yeah, I think it's good. I hope I'm not wrong. Okay. So it's going to be 2x I guess plus pi x, because I'm putting that negative on the outside there, over 4. All right. Sounds good. So, hoping for the best on that. We'll check our answer at the end, of course. So, let's do A prime. A prime, the area derived. Let's not even do A prime yet, because I still think I could simplify more. So I have 8x minus, I'm going to say a fourth, and then I'm going to say 2x squared plus pi x squared plus an eighth. I'm just trying to taking the constants out, so when I do the derivative, you know what I mean? Pi x squared. It'll be a lot easier. I can just leave those constants. Okay, now I think we are ready to derive. So that is 8 minus a quarter, take the derivative. 4x plus 2 pi x and then 2 pi x. Okay. If I had to guess, we're going to have some like simplification. Some things are going to kind of combine here. So we want to set this all to 0. So 8 minus x minus 2 pi x over that. So pi x over 2 plus pi x over 4. We're setting this all to 0. So I think common denominator is the way to go, as always. So 32 minus 4x minus, get so nervous I'm going to like multiply by 2 wrong, and then it's going to kind of ruin this whole video. But what can you do? I think we're good. Let's see. 32 over 4, yes. Negative 4x over 4, yes, is negative x. That's good, and that looks to be good. Okay, cool. So we want to set the top to 0. So 32 minus 4x minus pi x, actually, if you look at that. 2 pi x plus pi x, right, equals 0. So 32 equals 4x plus pi x. X can come out. So x would equal 32 over 4 plus pi. And that would hopefully be our critical number. I'm not going to use a number like that. I'll use a different number. 32 over 4 plus pi. I'm going to pause just to like kind of make sure we're still on track here. So just hang tight. Okay, of course my computer won't load the solution, so we're just going to have to go with it. So let's call this 32 over 4 plus 3.14, right? So it's kind of like 32 over 8, roughly. So it's roughly 4, I would say. So let's put in 10, and let's put in 1. Does that make sense? And then we'll scroll up and see what happens. So we're going to put in 10 and 1 into one of these. Let me try to do this. I think this is the way to do it. All right, I'll just move this. I'll just move this over here. And this is the critical number, 32 over 4 plus pi. Okay, so if we put in 1 here, I'm going to try to put it into this. It's not equal to 0 yet. Make sure that that hasn't been really affected too much by our, yep, it's just a simplified version of the derivative. Okay, so I have 8 minus 1 minus pi over 2 plus pi over 4. So I think this is going to be positive, but let's just see. 7 minus pi over 4, right? And pi over 4, I mean, that's a pretty small number right there, maybe 1 or something. So positive. And put in 10, we have 8 minus 10 minus 10 pi over 2, or just 5 pi, I guess you could say, plus 10 pi over 4, which would be 5 pi over 2. So we got negative 2 minus 5 pi plus 5 pi over 2. So we have negative, I guess this is 10 pi over 2. So we have negative 5 pi over 2 minus 2. So we have a negative here for that. So there's a maximum area when x equals, we know it's this, since a prime changes from positive to negative. Okay, so I'm going to pause and see if I can get the answer one more time to be sure before I make this public video. All right, good news, bad news. Mostly good news, though. This is right, but it did say to find the dimensions of the window, basically. So we see that we have this, and then we had this. And so we know that this is going to be 32 over 4 plus pi. That was good. And then we need to find this dimension. I think they just wanted x and y. That's what they put in the answer key. So if that's x, we then need to just find y. So we would go back and use, I suppose, this to get y. So it'd be 8 minus 2x plus pi x over 4. Let me just steal this. Bear with me, sorry about that. Edit, paste. Okay, it's not there. There we go. Okay. That's a pi, right? Yeah. Okay, so it's going to be 8 minus 2 times 32 is 64 over 4 plus n. Oh, 4 plus pi, jeez. This is all divided by 4, so I could do that now, or I could do it later, but oh well. And then, geez, 32 pi over 4 plus n. 4 plus n, I keep saying. Oh, man. 4 plus pi. Okay. I don't know, not the most efficient, but we're getting it done. Okay, 64 divided by 4 is 16, so we have 16 over 4 plus pi. I'm going to stop saying n now. And then 32 divided by 4 is 8, so 8 pi over 4 plus pi. So I just divided those numerators. I mean, I'm guessing we need to just do a common denominator here. So let's do this. We have 8 pi minus 16 over 4 plus pi. And then we'll add 4 plus pi. And what we need to do is we need to have 8 of those. So I think we need to have 32 plus 8 pi. Right, now if I factored out an 8 there, I'd have 4 plus pi, those would cancel, and I'd have just 8. So I think that's okay. And this ends up giving us 16 pi plus 16 over 4 plus pi. I don't know. That's got to be pretty good. Let's pause and find out. All right, we have good news, bad news again. The good news is it's pretty fixable, but we just forgot to distribute this negative. So that makes that a negative, that makes that a negative. And then I think what happens is that those pi's cancel. Yeah, and you get that for your y. So that would be your y value, 16 over 4 plus pi. I'm going to stop calling it n. Oh my gosh. All right, that's it. That's the Norman window. So again, speaking specifically to this group, you're either going to have the rectangular page, the Norman window, which I think is probably hardest, the Norman window, and then somewhere in the middle, or maybe even easier than the rectangular page, a farmer with a fence. This is a classic one, and then there's another one where he makes a fence, and he decides that this is going to be one. Whoops. And he's going to put the sheep in one section and the pigs in another, so he like kind of separates it like that. So anyways, those are what you can expect, and we will talk soon. We'll see you in the next video. Peace.